Yes, I had taken you through up to this point. I will just continue from that point, that we break this into two equations that I have indicated here as A and B, and we generate their coordinates so that we can eventually plot these two futures on one graph. When we substitute in x as 0 here, we compute, we'll get 0. When you substitute in 1 there, you compute, you get that. And consequently, you'll get these as the values to two decimal places. For that, you can work out that. In the same sense, we look at y is equal to 2x minus 5. The easiest would be for 0. For x as 0, y becomes definitely negative 5. For y as 0, x becomes 5 out of 2, or 2.5. But we can take on other values like 2 and 3. For x as 2, we get y as negative 1. And for x as 3, we get y as positive 1. These points are now sufficient for you to be able to find the root, or to show that this equation has a positive root. So we consider a y against x plotting, and you are expected to use a graph paper, of course, but I will use my rough paper here. I will consider 1, 2, 3, 4, 5, 6, because I am sure that my greatest value of x is 4, considered there. And I will consider for y to run up to negative 5, because I have that as a value. And then negative 2, negative 1. For the values of y, because I have them in decimal points, I can consider to run up to 0.1, 0.2, 0.3, 0.4, 0.5. Now, if we plot the curve first, it starts at 0, 0. Then 1 goes with 0.38. We can say it is somewhere there. We just approximate. Then we have 2 goes with 0.27. We can assume it is somewhere there. Then we have 3 going with 0.15. We can assume it is somewhere there. We have 4 going with 0.07. We can assume it is somewhere there. If we took on 5, it will definitely continue with the trend around 0. So we join with a free hand for this one to obtain this kind of curve, which we can label as y is equal to x, e to the negative x. In the same sense, we plot 0, negative 5 will be over here. 2.50, somewhere there. 2, negative 1 will be somewhere there. We have 3, 1, which definitely will be high, somewhere high, because of the nature of our graph. 3, 1, we can ignore it. So this one is a line. You ought to use a ruler to join, but I will join it with a free hand, but not that you are supposed to use a ruler. Now, after joining it with a free hand, where they intersect, you come down and confirm that there is a root here, and this root can be read off, and it is positive. It is positive because, as you can see, it lies on the positive x-axis. So you will have shown that there is only one real positive root, because there is only one point of intersection between this line and the other line. This is what basically that required. As for the second part, you need to simply go through the procedure. Differentiate and get the details fed in this formula to get it rearranged. Your final expression expected if you've worked through should be x negative e, this should be squared, the negative xn minus 5, everything should be over minus x ne minus xn plus e minus xn plus minus 2. This should be a minus. This is what you would be expected to wind up with. And like we said, they are challenging you to find from the graph, to find the approximate. From your graph, if you are accurate, this value from the graph should be, your first approximation to be approximately 2.6 if you have drawn it accurately. So you take this as your first approximation and you proceed to use that to find to two decimal place, to 4 significant figures, to find the root that converges. The error range was given. I think that should be able to guide you to go through that number.